Hello and welcome back to another video. Today we're going to be looking at the second of 6 Calc BC free response questions from the year 2019. So we've got this kind of figure here. It's called S, I guess, and it's the region bounded by the graph. Yeah, okay, it's this. They give us this graph right here for 0 to rad pi, and they want us to find the area of S. So let's do that. Recall that polar area. In polar, we say that area, this is part A, area is equal to 1/2 of the integral from A to B of r squared with respect to theta, right? Well, here we go. This is, A is going to be this, well, it's not going to be there. It's actually going to, we're just going to use these values that they gave us for, this is going to be A, this is going to be our B, and so we have 1/2 integral from 0 to rad pi of this r of theta squared d theta. And I'm not really trying to actually do that by hand. So I'll just get this out. What does that look like? See the integral from 0 to square root of pi. And first, of course, remember to multiply by 1/2. And it's of this r of theta, which we have right here, is going to be 3 rad theta sine of, sine theta squared, and then all of that squared d theta. And that gives us 3.53429. So that should be equal to 429, all right? And so that should be the area of S. That's what I got on the AP, so hopefully that's right. Let's continue. What is the average distance from the origin to a point on the polar curve? R of theta equals 3, well, that's just R of theta, 4, 0, less, okay, in this range. So what is the average distance? Well, that sounds a lot like average value, doesn't it? And the reason because average distance is actually just R of theta, right? When you think about distance, when you think about R of theta, you're thinking about the distance from the origin to any point, right? This distance right here is going to be your R of theta. And that's just that, right? So if you're going to take the average of two distance values, you're just going to say here and here, just going to take this R of theta, and then you're going to take this R of theta. You're going to add them up and divide by the amount. So what we're going to be doing for these average distance, this average distance thing right here, is we're actually just going to integrate its average value, right? So what we're going to do is we're going to integrate, and then we're going to divide by that same thing. So let's put b up here. B is just going to be 1 over b minus a integral from a to b of r of theta d theta. And this is the average value formula, so that's a good thing to know. And here it is coming in handy like that. All right, so it's going to be 1 over rad pi, because it's rad pi minus 0, integral from 0 to rad pi of this r of theta function right here. And if we plug that into our trusty n-spire, let's see what we get. Right here, 1 over rad pi, and this is 0, 2 rad pi of r of theta yet again. Now, it's kind of unfortunate that I can't copy and paste, but this is what you have to deal with when you don't want to use the TI software itself, because it's hard to move around the screen. All right, theta squared, and we're not squaring it again, so don't accidentally do that. That's probably a bad idea. D theta. To get this value, 1.57993, it's about 1.58. 1.58. All right, next. There is a line through the origin with positive slope m that divides the region S into two regions with equal areas. So it's going through here, it's going to divide it in half. Right. Write but do not solve an equation involving one or more integrals whose solution gives the value of m. All right, so first we need to think for a second. What is slope going to be in terms of polar? Because right now we're in polar, right? We've got r of theta over here, r and theta, and r and theta, and r and theta. We're not really seeing any y and x, are we? No, we're not. So let me take this stuff and move it over a little bit. Whoops, I did not mean to do that. That's also not meant to happen. Okay, whatever. I'll just scroll down. So for C, this is part C, we're looking at m. Now what is m? M is the slope, right? But what is slope going to be here? Well, we know that usually we've got our line like y equals mx plus b, right? Slope is going to be your distance, right? If this is a line with slope m, then this is your distance y, like how much you go in y, over how much you go in x, right? So usually m is equal to y over x. But what do we really have here? We only have like theta, right? So what we're going to be looking at in order to get this in terms of theta is a certain thing called tangent, right? Yeah, okay. We're going to be using tangent because here's our triangle, here's our y, here's our x. Yeah, okay. Now this is our theta. What kind of function can we use to get our theta? Yeah, we're looking at this appears to be opposite. This appears to be adjacent. Looks like we're using tangent. So tan inverse of y over x is equal to theta, right? Yes. So this theta actually just becomes equal to tan inverse of m. So we're going from this, we're trying to find m, right? So, but they just want some integral things. So I think we can use just tan inverse of m there, right? So if we're looking at our S region over here, and say we're going from this pi, this 0 to rad pi. I mean, we're not just going to divide by, we're not just going to divide rad pi by 2, of course. That's kind of a little bit of a taboo. Also, it just wouldn't work because, as you can see here, let me just erase this stuff because it's kind of in the way. So you can see here, this is not really symmetrical. It's got this bump over here, where usually it might be like over here, right? So it's not really a symmetrical shape. So doing that kind of thing isn't going to work out for us very well. So we have to divide it by 2. Okay, well, let's think. How do we get the area? Well, we already did get the area, right? It was 1/2 a to b of r squared d theta. So let's just do that again. A equals, okay, A equals 1/2 integral from a to b of r squared d theta. Well, if we're looking to divide it in half, then wouldn't it be a good idea to maybe just divide this thing in half? Wouldn't it? I think it would. And we can set that equal to the integral from 0 to some theta that would divide it in half. Now, what theta might divide it in half? I'm thinking, yeah, I'm thinking about this theta right here. That could be a good idea to divide it in half by, right? 0 to, and what is this equal to? Looks like it's equal to tan inverse of m. So that's what we're going to be doing. Integral from 0 to tan inverse of m. And it's of the same thing, of course, r squared d theta. Right, makes sense. Except for a certain part over here. Like, what are these a and b doing here? And it's divided by 2 again? Like, what's up with that? So are we just gonna let that go? I don't think we are. I think first, what we're gonna do is we're going to take out this 2 and make this into 1/4. Take out the a and the b. So let's do that. It's 1/4 now because we divided it by 2. This is going from 0 to just rad pi. I think that's pretty simple. And really, that's all that we need to do. I think it's not bad. Yeah, just write but do not solve an equation involving one or more integrals whose solution gives a value of m. So if this is solved, right, if we took this, let me move this a little bit closer together because it's kind of taking me off. All right, if we took this and we're just like, all right, we're gonna put this in our n spire. We're gonna go like solve this for m, like that would give us an answer. M equals whatever. Like we would get an answer for that. So I think that would work out. Of course, we'd have to put in like r of theta here and r of theta here, and that'd be kind of a hassle, but we could definitely do it. All right. For k is greater than 0, let a of k be the area of the portion of the region S that is also inside the circle r equals k cos theta. Find limit as k approaches infinity of a of k. All right, so that's a lot of words, but what does that really mean? Let's take a look at it. For k is greater than 0, let a of k be the portion inside the circle r equals k cos theta. Well, let's draw let's draw this mythical circle on the axis right here. What does a cosine theta circle look like? You know that for sine theta, something like that. And cosine theta is like this, right? Because it's on the x-axis. Yeah. And then this is our diameter. And that diameter, right, happens to be this coefficient of the cos theta term. So d cos theta, or whatever you want to call it. Anyway, here we have k cos theta. So our diameter looks like it's going to be k. Right. So what does that mean? What does that limit mean? Well, the bigger picture is that, well, let's just draw some potential k's, right? Say this is 1. Then it looks like our circle is going to be about like that. What about 2? Right? Looks like our circle is going to go all the way to 2. And so on. But what does this mean about the area that's encompassed by these, right? This is encompassing this much area. This larger one is encompassing this much area. What is this eventually going to mean? Well, as we can see here, these circles, as they get larger and larger, they're getting progressively more flat towards the edges, right? Specifically over here. This is becoming more flat, and eventually it will encompass all of this, right? And then eventually just the entirety of quadrant 1. So, and also, of course, quadrant 4. So really, these circles will eventually encompass the entirety. We're drawing a really big circle. You know, it's leaving the page and whatever. Maybe it's going to come back around here. Yeah, that could happen. That would encompass the entirety of this area. Of course, it would also encompass the entirety of this area as well, but we're not going to do that, right? So it would encompass the entirety of S as long as it's only in this quadrant 1, and quadrant 4 as well. So really, this limit, this limit as k approaches infinity of a of k looks like it's just going to be this area right here, not this little sliver over here, right? Now, how do we have an expression for that? Well, think about it. We only want quadrant 1. So this is theta equals 0. This is theta equals pi halves. Now, looks like we're just going to integrate over that. And you know what? That would be correct. Limit as k approaches infinity of a of k. Let's see if we can, I'll just write d over here. Limit as k approaches infinity of a of k is equal to the integral from 0 to pi over 2 of r squared, well, it's actually 1/2 that, r squared d theta. And then if we have to find that, we're just going to plug in our r squared. We can just go back here. Let's go up a little bit. And we're going back over to here. So instead of saying add pi, all we're going to do is say pi over 2. Pi over 2. That should give us our answer, 3.32447. Right. Equals 3.32447. There we go. All done. Thank you for watching, and I'll see you next time.